Gargantua. The black hole from the movie Interstellar that held the keys of solving humanity's problems.
I don't know much, but I've heard this movie is pretty accurate. Can you explain black holes to me?
This is a Schwarzschild black hole. In this theoretical world, this microscopic black hole has existed eternally, is not rotating, and is neutrally charged.
So, is this Gargantua?
Not quite. Gargantua is a supermassive primordial rotating black hole at the center of its galaxy. Our black hole is quite dissimilar. A Schwarzschild black hole's radius is determined by this equation, where Rs is the radius, G is the gravitational constant, C is the speed of light, and M is the mass.
Since these are constants, that means the radius is proportional to the mass. Then we can get rid of these constants and make this a proportional equation. What is the orange glowing thing?
That is the accretion disk, formed from infalling material as the black hole feeds, such as those constants you threw into the black hole. See, material cannot simply plummet straight to the singularity. Any tiny variation would cause the material to miss the black hole and enter orbit around it. And orbit it does, nearly at the speed of light. The accretion disk serves to bleed off orbital energy through friction to allow matter to pass the event horizon. As much as 6% of the E equals mc squared energy can be extracted this way.
That makes sense. What about eternal and primordial? What's the difference between those?
Our black hole is in an eternal static universe. We can sketch a Penrose diagram to plot our black hole. Let's say the black hole is on the left side of the diagram. An eternal black hole has existed since the infinite past and will exist forever into the infinite future.
What about the Big Bang?
Hold on. We'll get there. Since our universe has not existed forever, an eternal black hole cannot exist in our universe. Nevertheless, it must have collapsed at some point. So we'll mark that out on the Penrose diagram.
So, is the black hole not eternal anymore?
Yes. We'll say it formed during the Big Bang like Gargantua.
Next, rotation. How can a black hole rotate? Isn't the singularity a point? How can a point rotate?
This is where the Schwarzschild solution ends, and where we move to the Kerr solution describing a rotating black hole. In a Kerr black hole, the singularity is not a singular point. Rather a rotating circle or ring. A ringularity, if you will. Angular momentum is a conserved quantity. Recall how the infalling matter accelerates around very quickly into an accretion disk.
Yes.
Well, this immense angular momentum does not vanish. Instead, it is one of the three quantities described by the no-hair theorem: mass, charge, and rotation. We can increase the rotation by adding mass at a tangent to the black hole's surface.
What's happening to the space-time?
That's the ergosphere, a strange region where everything is forced to rotate with the black hole. Traveling prograde with the spin results in gaining energy, and retrograde results in losing energy.
It doesn't really look like that in the movie.
Because this is one instance of artistic license done by the producers where red shifting and blue shifting were toned down significantly. We're not done with our black hole yet, so let's go back to it.
Where did the black hole go?
Looks like we overspun it, and now it has lost its event horizon. The spinning of the black hole has overpowered the gravitational force, resulting in a naked singularity.
Can we remove some spin to bring the black hole back?
Of course. We just add mass against the rotation. Like this.
Cool. Can we get rid of the black hole?
As in naked singularity or...
No. Permanently.
Well, we will need to wait then, for 2.1 times 10 to the power of 91 years. Luckily, I can just fast forward.
Is this Hawking radiation?
Yep. Black holes will evaporate after a long time. Overall, I rate Interstellar 5 out of 5 stars for scientific accuracy around the black hole.
Christopher Nolan did ask actual astrophysicists after all.
Thanks for watching.